Okay, today we are going to be looking at reciprocal functions, and really what we're going into is looking at the transformations on them. So it's the same transformations we've been dealing with throughout all our functions all year long. And so whether it's inside or outside the function looks a little bit different, but we'll see where the inside is and where the outside is. And this is going to be our horizontal shifts and our vertical shifts, as well as our vertical and horizontal stretches and shrinks. So our parent function is the fact that it is y equals 1 over x, and the horizontal asymptote is at y equals 0, and the vertical asymptote is at x equals 0. So if you look here, the green line is our horizontal asymptote. That's the y equals 0. The blue line is our vertical asymptote. And so our domain, this is one of the functions. Remember I told you at the beginning of the year there's a few functions that your domain is going to be affected, and this is one of them. So our domain in this case is from negative infinity, comma, 0, parenthesis, this u, that means union, 0, comma, positive infinity. This is if it's in interval notation. If it is in if we're using instead the inequality form, it'll look a little bit different, and I'll show you what that looks like in just a second. So what it would look like if it's an interval notation, it's very similar. It's just going to be, oops, my pen's not working, just a second. Good. Okay, let's try it again. Let's see if it'll start working. It's going to be from y is less than 0 or y, excuse me, I'm doing domain. X is less than 0 or x is greater than 0. So it's the same idea, but written out in inequality format. Your range is going to be using the y's, and so looking at the y's, the only thing that we're not able to be, the only thing, these asymptotes mean that we're not actually going across that. And so our range is your y values, and it's going to be from negative infinity up to 0, unioned with from 0 to positive infinity. And again, if you wanted to have it in inequality format, it'd be y is less than 0 or y is greater than 0. Another way of writing this is x can't equal 0, y can't equal 0. So that's another way of writing the same idea if you're using inequality. So either one of those would it be acceptable. If asked for an interval notation, you have to use the one with the u. If asked for inequality form, the other one's the way you would go. And so this is the parent function. This is where we start off for our transformations. And I just kind of showed you the table of values. So when we graph -5, it graphs as 1/5, -1/5, and that's where we go over here, and you'll see it's graphed really close. Oops, here's 1/5, really close to the y-axis. And as we're going closer to 0, we're getting bigger and bigger values. At 1, we're at -1, we're at -1. And if we did x was -1/2, that would be 2. X was -1/3, that's 3. X is -1/4, that's 4, -4. And so you can see how this is getting taller and taller the farther out we go. At 0, you'll see that's undefined. That's because there's an asymptote there. It will be undefined where there's asymptotes, and then we'll talk about some other ones later that have holes. We'll be looking at those tomorrow. And when it's a hole, it's also going to be undefined. So let's go ahead and look at some of these transformations. So the first transformation we're going to look at is when there's a value above, kind of like where our K was. And that can cause, this blue line is the red line is the parent function. So that blue, that 5 caused it to stretch vertically. It's like I pulled the top and bottom and pulled it apart, and you'll see it stretching in. But if instead I use like a half, it's like I took the top and bottom of the graph and pushed it this way. But what hasn't changed is I still have the same asymptotes. So my horizontal and vertical asymptotes are both still in the same location. Those have not changed throughout this process. But what if I put a negative sign for A? If I put a negative sign for A, like -3, what it does instead is it flips it across the x-axis. So what was graphed down here is going to graph up here. This is a little bit more than that because I put a -3, and so it also did a stretch vertically on it as well. So let's go ahead and summarize that. The A, the number that's in the numerator, will cause either a vertical stretch or compression, and it will reflect across, it can reflect across the x-axis if it is negative. So the rules for this is if it's negative, it reflects across the x-axis. If the number is, the absolute value of that number is greater than 1, it's a stretch. If it's between 0 and 1, it's a compression. And again, those last two are looking at it as the absolute value. So we're not considering the sign. We're not worried about whether it's positive or negative when we're looking at the green and the purple changes. And again, there are no changes to the asymptotes or the domain and range. So let's look at the next thing. So this time we're taking and adding something to the entire function. So on this one, we have, it's like we took the graph and moved it up. And our asymptote, yellow doesn't show very well. Let me choose a different color. Our asymptote has moved up from the original location. So here's where it was originally. And it's like I took this graph and I moved it up. But the vertical asymptote has not changed. So this one has shifted up 3 units. That 3 came from that 3. So let's look at a couple of other ones. I'm just going to play with this in Desmos. So if I had a -4, it moves the graph down. And so I have moved down here. My vertical asymptote has gone down to -4. If I did a -0.5, then I shifted it down a half. If I had a positive 1/2 that I added to it, I shifted it up a half. So all it's doing is taking the graph and either moving it up or down. So in summary, that D moves the graph up or down however many units. If it's negative, it moves the unit, move it down. If it's positive, it moves it up. There are no changes to the vertical asymptotes, but there is a change to your horizontal asymptote and range. And so the y equals D is going to be your new horizontal asymptote. So we're going to look at what happens when I add or subtract in the denominator. And remember, this behaves opposite. So it's not, we're going to go opposite whatever it is. So if we added 3, it'd move left. If I was subtracting 3, I'd move right. And so if you can see that here on this graph, I've moved right 3 units because I subtracted 3. But my horizontal asymptote hasn't changed. It's still at y equals 0, but my vertical asymptote has moved to x equals 3, which is the opposite of what this is. So let's look at a few of them and see what happens. So as I look at this, if I want to take and add and subtract in that denominator, so let me go ahead and get rid of that. So we subtracted 3 is what I showed you on that graph. But what if I added 3? Which way do you think it's going to go? If you said right, or so you left 3 units, you were correct. And so we're looking at the changes in that blue. If I added 9, it's going to go right 9. If I subtracted 7, it goes right 7. I think I said that backwards on the last one. It was left 9. So whatever I put here is going to behave opposite. So if I put a minus 7, it goes right. If I put a plus 7, it goes left. And so let's go ahead and summarize what that's doing. In summary, that C moves the graph either left or right, however many units we say C is. If it's negative, it moves it right that many units. If it was positive, it would move it left that many units. There are no changes to the range, the horizontal asymptote, but there is a change to your domain. So we said that the domain, we moved it over the opposite of that C. And so it's going to be x equals C, because remember it's subtracting the C in the denominator. And the last one, and we really haven't talked about horizontal stretches and compressions. We really focused in on vertical. But if we have a horizontal stretch or compression, you may see these a little bit more now because sometimes the fraction will be written to where it's in the denominator. They kind of behave opposite of the vertical stretches and compressions. So here's an example of y equals 1 over 4x. Again, just like on the stretches and compressions earlier, it didn't change my asymptotes. My asymptotes are at the same spot. That means my domain and range aren't changed. But if you look at it here, if I'm thinking about it from a horizontal perspective, it's like I pushed the graph in. So when with that 4, it's like I compress the graph. Let's look at what happens as I type in other numbers. So let's say I tried in let's put it back to what we had, 4x. So it's like that graph was pushed in from the left and right. But if instead I put it at 1/4 x, it's like I pulled it apart, pulled it away from the y-axis. So it was a stretch horizontally. If I put this as a negative down there, then it's going to reflect across the y-axis. And honestly, you cannot see a difference between the reflection across the y-axis or the reflection across the x-axis in the way it's graphed right here. But you can as you start adding more transformations sometimes. The thing is, watch where your negative is. If it's in the denominator, it's a reflection across the y-axis, and if it's in the numerator, it's a reflection across the x-axis. So when you're graphing these on the graphing calculator on the Math Excel, that's where you need to look for it. Was a change happening in the denominator or in the numerator? And that's going to tell you if it was a vertical or a horizontal. Horizontal is going to be in the denominator. Vertical is going to be in the numerator. And so let's go ahead and summarize what this looks like. So in summary, that B is going to cause a horizontal compression or stretch, and a reflection across the x-axis or the y-axis. Excuse me. If it's negative, it reflects across the y-axis, and if B has an absolute value of greater than 1, it's a horizontal compression. So it's almost like it's opposite of what we dealt with before. And if it's between 0 and 1, it's a horizontal stretch. Again, there were no changes to domain and range or asymptotes in this case.